Okay, everybody, we are ready. So welcome, Alain. He will introduce us CRUD+V NSO packages. I mean, it's quite interesting to see how he's doing verification with CI/CD pipeline. So everybody, welcome,
Thank
Alain.
you. So what the previous presentation was about, I'm actually showing it in practice how we are doing this within our team. Just for the guys that are here, there is a small gift that I have for you guys for your 50 minutes of attention. So, but I don't have enough of gifts, so we do a little drawing at the end of the present or during the break. I just invite you to write your name on a paper and you hand it over to the next one, and then I will draw at the end of the session. You are possibly somebody that can win some things. The hints of what the gift is are going to be revealed during the presentation. I'll give one hint. I'm from Belgium, and then you think about two things, I think. But you will see during the presentation, you will get an extra hint. And there is a hint. Didn't last that long. Just to tell, I'm from Belgium, but you see the little square there. That's the region where I live. And the important thing is that living in a region where we have special breweries that bring out these beers. We call it Geus. It's a special beer because it's a kind of blending. It takes very young and old lambic beers and they merge it together. And I'm actually, well, it makes that you have a lot of other different blends that they can make. And I would like to make the comparison with some products within Cisco itself that I know about. Actually, I don't think I mentioned that actually when I started my career in networking 25 years ago, 20 years of that was within Cisco, well, almost, before I decided to do some other stuff and become more technical within Belgium itself. We talked about it, the CML2. That's from we do old Geus. That's a standard beer that they brew. You have a black label, that's a special edition. It only comes out from a brewery every 2 years. The bottom one, that's a special one, has the cherry on top of it, and that's what I call my pyATS. That's the special brewery that I can use for extracting parsed data from whatever device I can talk to. The whole blend, that's a mega blend. It's all the different breweries in the country or in that region that brew a special, that take from their own stock a little bit and merge it every 4 years. So that's a very special mega blend. And I compare it to the NSO in Docker that was discussed in the prior session here. So my idea was we were using all these frameworks separately. CML2 is very neat for us. We mainly have Cisco devices, but we have also a second vendor in our network. And we are actually, well, what we are doing is when in the network engineering team, when we try to release something on production, we go and test the feature, and then we start to do it in a CML environment, so in some cases. We'll talk about what we did with NSO and NSO in Docker, but I have a question for you guys. Who is using NSO in Docker today in their environments? Who is using just NSO simple install? Okay, so I'll make a comparison because this is where we actually started and we moved into NSO Docker, and that has been helping us a lot in development of all these things. Who knows more than 4 frameworks that I discussed here? The pyATS, the CML2. Who knows 3 of them? Okay. Who knows about beer? Oh my God. That's the Belgium guys, right? Whoa. And you know about girls. So we were using this separately, and we wanted to come to a possibility to actually, what frustrated me a little bit is when we started to use NSO is it's just config management. You push config, but you don't know in the end if your config is working. Yeah, you can use NetSim devices, etc., but we just heard in the previous presentation what the drawbacks were. I wanted to combine it with CML2 and with pyATS to do the additional verification and make sure that I can put in my Yang service model for a service some specific items that can already pinpoint to operations what is happening. And that's where I want to blend all these things together. And that's where I actually started my quest. It's the second time I showed it. So next slide is going to be around that, how it's done. I demoed it last week to my team in DSTNY itself, how we do it. So it's a public announcement how it's done. Not sure. This is actually a service that we developed. It's an IPsec tunnel laid to LAN tunnel. It's not even playing, I think. So push next. And we use actually the NSO in Docker instance. So this is a package skeleton. So you have several skeletons. This is just for us, for our coders, to start developing a service. It's still not running. Should I do something else? Come on. Help. And you know shortcuts to make it play? How do you get to the screen? Because I know. There is my little mouse. It's running already. Okay, it's running. Oh, damn. No. Oh, can you do this? An apple and... Yeah, there we go. Thank you. Okay. So, is it now? I see something else. It's running, not. Yeah. Yeah. Cool. I'm already apologizing. It goes very slow. It's not because I'm a slow typer. It's the CPU on my PC. That was a little bit when I was using this video capture. So, but this is the package, and it needs already 2 bash variables, and that is the NSO version on which I want to test the package, and what test environment that I want to use. You can see I have 2 of them. The quick one is where you would, that's the standard in the package, and that is where you would have the NetSim devices. The other one, we will see it more in detail in the next slides, but that's where I start the CML2 instance. First thing that I do is, of course, I start up on my local laptop a test NSO instance. So in this package, if you do make build, you have your test NSO, and that's the one that you use. You see that I'm also loading in directly some files. The authentication group is to help my connection that NSO will make to the virtual devices I'm spinning up in CML2. So just to show you what I did as a commit. So there is the authentication group that I'm enabling, and there is also Well, I'm making a local user because I'm going to use a web UI also on NSO. Slow typing, I know. I'm embarrassed. But that's all incorporated in that package. So NSO in Docker gives you all these capabilities. It's not something that we have been programming. It comes out of the box on this package. Starting up the NSO web UI just to show you that I have the capabilities, that there are no devices in it. Because what I want to do is I want to start up a lab, do my testing, break down the lab. Just to show that there is no magic, that I didn't do anything that is already pre-configured. I'm showing that there is no device at all, that I'm going to first start CML, and then I'm going to populate it, everything in NSO, do the device sync, etc. For those who don't know CML, this is a dashboard. What will happen, you'll see there is nothing on the bottom. I'm now going to have a special target instance in this package that is going to trigger Terraform plugin that is talking to CML over the API that CML supports. And there you got the package. You see it already. I'm firing up a simple lab where I will configure these devices. This is my service that I want to test. The other device I'm using it also, I'm also going, because I need to reverse also, I need an end-to-end IPsec tunnel between both of them. So the Terraform plugin, it's really holding until all these devices are booted. And then it stops. And then I can continue with my process. So that's all the output from the Terraform plugin. You saw it took a little bit while, but if you remember the DT, if you take an ASR9K, you're gone for 15 minutes. This is just, I have the possibility to go via an out-of-band on my devices. Just to show you, show crypto, nothing was there in the beginning. And this is actually now where I'm going to sync. I have my 4 devices now running. I'm going to hook in on the IPsec terminator so I can start to configure it. And that means that I need to already connect to the devices that are running in CML, fetch their crypto material, and then do the sync from. You see the out-of-band in the, just the blue lines were actually in CML2. This is where you now see that the devices are now popping up in my NSO and they're ready to work. I'm now doing via API calls the configuration of the service, so the CRUD operations, create, read, update, delete. The read is just checking if you have something configured on a device name. This is going to configure on both sides an IPsec tunnel, and they're going to, what I'm going to verify if the tunnel is indeed working in this stage. So I create the tunnel. I created actually 2 tunnels on both sides, one. I got my 201, means it's good. Going to show you that indeed via the CRL, see on the NSO device, there was actually configuration requested and that it was done via REST API call. Typing slowly, you know that. It's really the CPU. So the call that I made from my Postman was actually my REST API call. So when I look at it, it's really showing the configuration that I did. So that was the JSON body that was part of that API call from Postman. So you see the both tunnels, the aggregation tunnel and the CPE tunnel. So for us in production or in real production, my delivery team only configures something on the aggregation point, and it's up to the customer to have the same comparison. And that's why it was important for me to also have a kind of verification. Why? if my customer on the other end screws up, I want to give my delivery guys the possibility to check these things without having to go what I'm doing now on the device. So I'm doing show crypto IVRF and making sure that it works. You see the tunnel is up. My service is working, but this is now on the device. I want to give the interface to an end user or an operational guy that can check these things. So all these things that I'm doing now, the ping tests, that's things that I can actually use via live status. I was actually also in pre-sales, and if you can ping the device, that was a motto in Cisco, if you can ping the device, you can triple the price. So that's already a proof that it worked, my service. So next call that I'm going to do is I'm going to do repeat the ping via an NSO API, and that's the live status. That's something that you have in NSO available. This is not a verification, you can already do that. But the different thing here, the result what you see here, it's unparsed. That's not good because I want to filter it out and put it into my Yang model in the end. So I want to I don't want to do start scraping of text within my Python package that I have on NSO. This is what I do via pyATS. You see now that I'm already doing a scraping. I did the exact same command, but now it's via my pyATS module that is coupled in with my NSO. And at the end, if everything was verified, I saw my tunnel was up and active. My guys are now reassured that everything is correct on customer side also. Now I can actually, well, the last thing is in this CRUD operation, I left out the update. You can see what an update would do. I would test all the different elements just to verify that they work too. Because in my Yang model, I have choices, etc. I want to test all the different choices and make sure that my tunnel still works. It takes a little bit longer, the deletion. It's because the crypto, it's not that easy to delete something. There is always something remaining, and that's why you need to have some time to remove everything. But it cannot go wrong. It will be deleted at the end.
Maybe a question while we wait for that. So you basically built a pyATS package which wraps pyATS, and you can import it manually to the user statement.
After the demo, I'm going to go and show you the things, how it's done under the hood. So your answer, you will get your answer in 5, 6, 7, 10 slides within 55 minutes. So just to show you that this is actually a commit change that said delete my service, and it's only on aggregated that I deleting this. So that was removed, and now of course I'm going to verify again that show crypto session is gone. And the rest of it is just cleaning up. So I'm stopping my CML2. And you see that the Terraform plugin is now sending an API call to tear down that lab. You see here, lab not found on my dashboard. It's because it was removed by NSO itself via an API call. The same thing here. What you will see is now I'm going to tear down the NSO. That's the last step, my test NSO. And I will lose, of course, then my connection, my web UI, and etc. So this is all done now manually. And that's actually where I started to play around with the robot framework, because it can do the REST APIs for me. And it can actually do all these things, all these steps, build up the lab, tear down the lab, do all the functional testing. It can do that all for me. We're going to go over this robot framework, etc. Also all the things that I'm doing here. But you can see it's the same thing. I'm starting up a test in the Docker container, starting up the CML2 lab, doing all my CRUD operation plus verify, and then I'm tearing down everything down. So I'm tearing down. So during the verification, but I'm going to come back on that. So during the verification, I'm really looking if my tunnel is up and running. Robot framework, this is on the local, what you'll be seeing on the CI/CD. It's the same thing that you can represent on. We are working with the GitLab infrastructure also. So everything that we do here is going to be pushed. If I done my coding of the package itself and I commit, it's going to be a runner that I spin up in GitLab to do the same thing. It's not yet doing this with CML2, but we do it already with the NetSim or with the quick test environment. This is just to show you again, I do some logging and showing that, well, if something would have failed, I would have seen already a red flag somewhere. But this gives me the certainty that if I started to code something and I break something, I would see something that is going to fail, right? REST API call that we are doing and the syncing of the devices. During the rep of the robot framework, gives me also the possibilities to do additional checks. I want to see that if I do something, it needs to be a certain response code. The 201 saying, I accepted your commit on NSO. I'm just trying to create everything now on the devices, but everything was good for me. I think my presentation here stops. I guess. No. It's restarting. Yeah, so that's finished. So that's a little bit the demo. Right? That's what I call my perfect marriage. And I now have a service package that I can continuously repeat all the testing that I want to do with it. And we have a beer for it, a Geuze beer. It's called Mariage Parfait. For the French people, you understood me. Well, I think even in English, you understood me. So, but this is really what I was doing manually by the postman. That's the entire repetition of this. So let's digging onto the hood and let's start with, whenever you start a network automation process, it's as good as. We'll see the service model, how I extended it with the verification capability, because there are different possibilities. It depends on your needs, and it depends on how far you are, or how far pyATS is. And then, of course, the robot framework, I will highlight how it's done. When I come back to network automation, I have a book. Benoit Claes was a guy that worked with me in the TAC when I started in Cisco, so I know him really well. I was even with him on a TAC rotation in RTP. Wrote an excellent book about Yang modeling. Excellent read. I think Jan Lindblad from NSO Telef was also one of the co-authors of this. But I'm starting from this because your network automation is going to be as good as your foundation and all the tool sets you build around it. And that's what he's detailing here, and automation is as good as, and what you can do with it. A little bit on the organization for which I work. So DSTNY, before it was called really DSTNY, but when they started to expand, there was suddenly somebody that had a patent on the name, and they actually threw away all the syllables from it, and we still call it DSTNY, but it's without all the things. So I started around 2019, and it was still a small company in Belgium. And 5 years later, we started to acquire all things. And that is actually where our CTO was stressing us why we needed to have network automation. It's not that we want to do something in our current network. We had already some tools available. But when we started to acquire companies, there was always a small surprise, and then we had to do quick migrations towards some of our equipment. So his demand was, well, it's all these acquisitions that triggered for us these network automations. And we started to consider every acquisition as a greenfield for us to start to do something to automate the service for us. So that's a different mind shift than what you would have in the bigger SPs that are really more in, or the incumbents. So it's a different mind shift. And actually this one, easy consumable services, that's the only thing that the CTO said to me. It needs to be easy consumable. And we went, well, just a small joke. When we were doing acquisition, you see here Belgium Telecom. In the press, they announced that DSTNY acquired BT. I can tell you, people were really going, what the hell? But we did not. It was Belgium Telecom. You never know, probably when we get home. So this is where our network automation journey started. Well, I had a Cisco background. I know about TLF, but they were introduced. They had to do the same POC together with a few other vendors, and we just gave them a kind of use case that they had to solve for us. And with NSO, we were seeing directly all the capabilities. So for us, we started already to work with NSO in 2019. The little kid that is jumping in the water, I have a daughter of 10 years old. When she was young, she was too, well, it was very dangerous to leave her alone where there was water because she would jump in it and she couldn't yet swim. So we went with her to swimming lessons at 4 years. But those swimming lessons, if I compare it to when I was young, I had also swimming lessons. I remember my first swimming lesson ended by having to go and jump into the deep. And that was exactly what I was thinking about when we had to do this type of work. My daughter was easy. They had to do some water over their head, and that was the first lesson. So one of the mindsets also, and that was a big gratitude on a system engineer from Cisco that helped us during the first code development that we were doing, and that is make sure that you don't bring in big monolithic services. So we started to carve down and have very small services. So my IPsec service, I will show it later on, the Yang model, you would see that there are some other sub-services in it. Luckily for us, when we moved to NSO Docker, it resolved a lot of problems also for us. Because here, when we started the system install, or our first, when we were rolling this out, we had 3 environments where we have NSO, so on our own local machine. It's not mine, that there. We had a local install of NSO. We had UAT to do some testing on real hardware, and we had production NSO. We are with 5 people in our team. What we noticed, 3 months down the road, it was snowflakes everywhere. Somebody was running a net element that was totally different, that somebody already started to use something else. So it was a nightmare to keep things in sync even between those different installs. And that was a miracle for us when we went to NSO in Docker. Because of these approaches, where we got skeletons, we could build things from base, use the nets, use the package skeleton, use the system skeleton. That's in actually the end product that you would use in your production, because it builds everything that you have already tested here. So you can use your base testing when you upgrade your versions. You can do net package testing. We developed our own net for specific voice application, was not involved. We developed our all our services. I think we, with all these small sub-services, I think we are now already around 60, 70 different, for everything a little bit. And it's also, well, with 2 vendors always in mind also. And Cisco is the special case where you have iOS XE and iOS XR also, of course. And all of this is integrated in GitLab, so what our previous presentation was showing. Thank you for that. Now I'm lucky because I had no slides about it. These CI/CD pipelines, we do it also. And what we do in GitLab is the result of this pipeline is always a result package. So it's the one that we're going to pull in when we are building our service. So for those familiar, you already see the directory structure. Even the guys that are developing on local install, you would see the packages. The rest is coming from the NSO in Docker framework. So, well, I added something, so the robot framework is here. And then my test environment, CML2. It's not a lot of code. I will show you later on. But what is important here, like I said, we have really small services that we are using, and it's really small. So BGP redistribution is just going into VRF and saying redistribute static. But now everybody can reuse that. So it's for us a big difference. And for the IPsec part, I'm using VRFs because I need to allow customer to open up an IPsec tunnel from the public and then being plugged into his own routing domain on our MPLS backbone. So with the includes, I can say what other packages I want to have here or that I'm going to reuse in my, and then of course all the network elements. So you see Oracle SBC, that's the other one that we developed. It comes along. I don't need it in the package, but it would fail because there is some dependency on the other packages with it. So here, the includes, it's pointing towards that Docker repository that I have in my GitLab server, and it's going to push, well, I have it. We split it up a little bit for clarity. When are we looking at a net package? When are we looking at an NSO service package? When are we looking at the builder, the NSO base itself? The documentation, a lot of README documents you have available in NSO in Docker. So you will have to look into the structure a little bit to find out all the README, but they are excellently explaining all these things that you're seeing here. So, but this was my biggest development improvement, because what happens now, every time that I do a make build and somebody in my team changed the BGP or the BGP distribute packet or the VRF, what is happening? As soon as I make the build, it's going to query and find out on my Docker repository on the GitLab if there is a more recent version. And he pulls it in and have the latest code from the other services. Before, if you forgot it, well, we were bringing it in as an extra package, and then you had to do a git sync for making sure that you have the last. But we forgot it always. So when we went into production, it was always a surprise sometimes. But this resolved it for us neatly. So let's look into that CML2. For starting up CML2, so a lab itself, I actually included 3 extra targets. You already saw them: the start CML2, the stop CML2, NSO staging. NSO staging is where I'm pulling in the devices. So if I look at that code, it's not a lot of code. So I'm actually using a Terraform plugin, and that was one of my last missing pieces. That's why it took so long, because I was even thinking on creating my own API queries towards CML to start up labs. But this guy came along, many thanks, I've forgotten his name, but you can find everything on the GitHub server. and this is an explanation on how to do this. If you follow those guidelines, you're done in 10 minutes. I just created these 3 additional targets, and you see it already, the Terraform init, Terraform plan, Terraform apply auto proof. That is all explaining these things, but it's just looking at this main TF that tells me how you have to talk to CML2, what is your credentials, what do you want to do? I want to start up a lab. And the same for stopping it, it's all Terraform commands, so you need to install Terraform on your local development, etc. NSO staging, that is of course, now I need to make the link, and that is where I'm loading in a device CML file for making sure that I have my devices available in the test NSO that I'm booting up. And then of course I do the fetch and the sync from it. So, but that are the 3 yellow files. This one, this is my CML lab topology. If you know CML2 a little bit, you can export your lab directly from there. It's a YAML file. It's just a matter of clicking the download lab and you have this all available. The extra thing that I'm doing here, this external, that's where I'm, this unmanaged switch that goes to an external connector. This is a bridge connector that is going to give me the out of band to these devices. There are some pitfalls here. So default configuration, if you do SSH login, yeah, you need to make sure that your configuration already has the crypto keys. I think you explained that also on one of your slides. It's very easy for me because in that YAML file, I can edit things. So I'm doing crypto keys, generate RSA, and I get that. You can tweak this YAML file to whatever you want. Just take into consideration that you have to use the /n if you want to take a next line, etc. But you can tweak it to what you want. Also take into account routers that you boot up. Default state is always shut down. So you really have to explicitly on the interfaces that you want to have on CML that need to be opened by default, do no shut in that config, which is a pain in the ass sometimes if you forget. But giving it with you, learning curve. CRUD operations, business as usual within a zone model. If you know your Yang service model, it's a simple service for us. It just defines what the IPsec, the overlay, the remote subnets, the local subnets. We do something weird also for the VRF. So the VRF service, we create it from within the service. We do it like that because it gives us the, well, if I would put that in the service itself, I'm tied to what NSO would do is the moment that I'm removing the service, it tears down the VRF also. So that's the other advantage of having this in another subservice. This is business as usual. Create, read, update, delete. That's what I'm doing with these REST API calls with my... the more difficult part is when it comes down to the verification part, because that is something that you will have to do yourself and that I struggle a little bit with. So when you read the documentation of NSO, if it's not configuration, the way to go forward is implement an action. When you implement an action, that is something that you put in your Yang model on the NSO site itself. You can see it's an extension of where I put a small container for pyATS. It's a parser action that I'm going to do. And when you, well, I call it a parser action. It's my naming. So, but referring to also the RFC, the chapter 715, what I need to use as variable or input or additional Yang elements, they are mandated by the RFC. So you don't have the choice. You need to work in action with input and output. And that's the reason also in your main in your Python template, you have to register an action and you're going to refer to your a pyATS class that is available then to do all the parsing. You see the linking, so from within my core or my domain, there is an additional pyATS parser Python file that I'm calling from within the action. This here, well, it's code from NSO. I'm going to make sure that all the output that I'm producing is going to be returned into my Yang service model, the additions that I did for, and that's where I now, well, I'm using a list for commands so that somebody can also review the commands that I've been executing on all the devices. I can now trigger or go into the session and look at the session state, etc., per device. Verification, you can, well, I've been looking around, so there are different methods to do it, and it depends on your needs. If it's just showing commands, you can well use the NSO device live status, but it's always unparsed, and then it becomes very hard to parse it yourself in your Yang service model afterwards. The other way you can do it is you can use a Python library, and then you have pyATS directly integrated into NSO. My problem is when you were when I was doing the show command, you were seeing that I was doing show crypto session IVRF blah blah blah. That command didn't exist in pyATS yet, so it's not yet there. I'm working on it to get it submitted, but it means that I need to have a possibility to pull in pyATS itself as a framework, and that's what I'm doing in these steps. In the addendum, you will see how I'm tweaking. What I'm doing is I build up another Python virtual environment, and I'm going to call it from out of my code. And then it's also, well, I was referring to what we are doing in pyATS. With the migration, sometimes we need to know the before and after, and pyATS is helping a lot with that. So I have my own, well, there are some scripts within our environment that, that I can recall every time that I need to do something different. There was something here in pyATS. There is an advantage if you can use this one, because this one works directly with your device CDB in the NSO. The other one is not. So I need to generate my own YAML file to tell pyATS how they can connect to my devices in production.
Yes, sorry to interrupt. The break has started. I think the session is very interesting, so, and the next session is going to be 20 minutes, so probably you can finish. And
yeah, I think I still have 10 minutes roughly,
okay, so
if you have time, and then
yeah.
I'll talk faster. So this is the pyATS class? So I'm calling actually this script, and that's why you see here my pyATS environment is actually somewhere within the NSO base on the this subfolder. I'm calling this NSO command launcher, and it expects from me just two inputs. It's a device list and a command list, and it starts to throw all the commands to my, well, it does it via NSO, of course. Here you get magic around it with the integration with NSO. So I'm actually trying to build up a device dictionary that can pass along. So I'm actually calling out if it's a device that belongs to my service. So I know what the IP sector is built on a specific device. I call it out, I go to search it, and I pass it on as my device list. This is still a little bit, well, maybe I'm going to do it in future a little bit different, but it's static. I know what I want to show my people when in operations. I know what commands I can filter out and what commands are needed to tell people how everything is working. So it's statically defined, but of course I need to know some of the things I've been configuring inside the service itself. And then, of course, well, the input, that's the, it's an enumerator. So in the container, the E stands for enum, and I'm just saying, well, if I would have different options in my command set, I would have different enums. But that's how I make the link between what command says do you want to see everything, or just IP routing? Do you want to see crypto, IPv2 status? Do you want to see the IPsec security association? Whatever you want to show in that command. So, but that's why I use an enum there. And all that input is going to be fed into a, so from within my parser class, I'm calling out to this pyATS as a subprocess, and I'm verifying if my, the return code, etc., is valid. And then I start to parse everything into code. So if it was a success, I start to parse it into all the different Yang service elements that I have. I got it into JSON, so it's for me easy now to really populate things within the output that I want to provide to my operational people and delivery people. That being said, it means it's available as an API call when I'm using it, or it's there also in the GUI, in the web GUI. If later on there is a problem with the service, somebody can pull these commands again. So it's a repeatable action now that I have in the NSO framework. It's not only therefore validating my service when I do the coding. Brings me to a feature request, and I was part of Cisco. I know the process. Some people are going to dive underneath their chair not to have to do this, because it costs you an arm and a leg to go to a product manager and ask for a feature request from a customer. But I'm going to ask it anyway. So if you're familiar with NetMiko has a specific flag that says use Genie. Use the parser capability if you have it installed. I would love to see this on NSO. Have a verification part. It would simplify my things, because then I can maybe interact with these CDP devices because these two different Python environments, it's disturbing sometimes. I could have control over what devices I send, etc. I don't have to do this pyATS, JSON, Yang, figuring it out how I put everything on the right spot. And that is actually what I would like to have too. I'm not asking too much. It's the capability to do myself some development on the pyATS framework. So if you try to integrate it, allow me to change things. I'm not sure with pyATS, if you're familiar, there's a separate class. It's called the constructor class. If you are interfaced to another device than a Cisco device, you can call your own constructor class and make it available. I did it for a few devices where I wanted to use pyATS to verify some certificates that were still valid or not. And it was not available in pyATS, so I created my own constructor there. So bring it all together. Well, this is a robot framework that I quickly go over and need these things. So I'm just using a hierarchical way of defining all the things. If you read the robot documentation, this is how they detail it, because this would allow you to define your test case. Everything is a separate test case for you. If you make a new directory, for example, I have test cases, functional tests, and this is where I do the create, read, update, and verify actions, right? The init robot is actually telling how to set up the test bed and tear it down again. And then, of course, the other file, the test bed resources, is what do I need in this environment to make it work? And I don't need a lot, we will see. But by using this, I can easily skip some things, because if I'm developing and I have to constantly, when I do robot framework start, whatever, the command, I'm not going to hold until CML is ready. So what I want to do is just, well, you can skip the init. I bring up the CML testbed myself with the make test environment, start CML2, and then I start to do the testing, etc. This is what I'm doing, the start test environment. You see the things already returning, the targets that I made specifically for this. In the robot framework, I can really say, well, look, if it doesn't work with the CML2, don't continue. So I'm doing an abort if I see there are some errors in my output. Test automation here, the package skeletons, what are the resources that we need? Well, I only need to have resources that give me the capability to REST API calls. So that's a request library and a JSON library because I want to parse it. The rest is some libraries that I'm using for, well, standard built-in libraries from the robot framework itself. And I have my environmental variables that I am actually using because I need to tell the robot framework how to talk to the NSO, right? And how to launch CMO, etc. Then it's only CRUD operations. You know these URI that I need to do for NSO. If I want to create a service, it's a post. The URI is what service I want to deploy, and then you need to provide a JSON body. That's the three files that you saw. The JSON body, the create JSON, I think, update, and then verify. So if I would do an update, it's the same thing, but I use a patch command, and then I give my JSON with all the different variables that I want to pass on. Deleting is just saying delete and the service that you want to delete, and you give, of course, the name of the service that you want to delete. The rest here, the post here is the pyATS parser. That's a special one because that's an action. And what an action needs is you need to give it a JSON body with input, show me all. That's the enum that I made, the enumeration of it. So this is my different calls, and that is how they are, well, the testing mid stages, what I'm doing here. There is a special one that I need to do because if I'm doing, when I'm bringing up the Docker instance, my IP address, because you could have multiple people, it's always a different IP address. So what I need to do is, I need to do something that figures out with the Docker inspect command, give me the IP address of my test NSO container, and then I'm just going to test if I can talk to the NSO container, and then I can continue my testing with CRUD operations. What I need to do is verify the IP address of the container. I use also tags, so I can really say now I want to do a creation, I want to do an update, only these things. I can include them, and I can exclude them with the tagging, the -I or the -E. So I include something, or do only this test, or exclude this test. And then I start to, well, this is just the HTTP session that I'm creating. You need your headers and talk to NSO, log in, and then you can start your REST API call. And there you see the format that you could do as an additional call, expected status 200, etc. To create just the same, the only difference here is, of course, the post on session and what you want to provide as a body. Update, delete, same things. Make the, bring up the HTTP call, do a post, a patch, and here do delete, and you specify the service name. So, then the last one, and that is a little bit different, because what I'm doing now is, even when I'm doing these CRUD operations, when I do the robot framework for my local device and I bring up the CML, I want to have a final decision in, is my tunnel up or not? So I need to go and fetch something from the response to see if my tunnel state was up or not. So, and if it would be down, I would fail the test, and otherwise I would take care, because the documentation was not that clear. You have in your response body, there is some, in the syntax, you can either use it with the JSON page or with the JSON extension. That's a Python dictionary. If you take that and you parse it, you would see you could do a validation of your JSON path with the JSON path finder.com URL. It would show all errors. You have to take into account that if you look at response content, you would see the JSON structure. But if you do a call to response.json, I was thinking that that would provide me the JSON structure, but it was a Python dictionary. It depends on how you do it, but now you can look up what the status was of my clone, and then I can check if it fails or not. Wrapping up, what do you think about it's a perfect marriage, or? Well, there is still some work, and you know that we had to do add some extra flavors, and those ones were added in at the end, obviously. No. But I can provide them. You know, I'm a salesman. Well, in the past, you get a French prize, because I know you're already so long on it. So, it's very hard to get there. It was very hard to get at the stage, but I think now I have all this capability to do not only control plane testing, I can also do data plane testing. It's not given that you can test everything simultaneously. Don't try to do a VPN with it. Maybe it's also a feature request. But and this is very reusable. I can take this robot framework and copy it to all my other services. I can take this test environment directly, flunk it over to all my other packages, and I can do the same. And I know which packages I need to. Do you want to have a different test setup? Use a different YAML file from CML, and you have a totally different stage. We test up to 40 nodes. Sometimes we spin up 40 nodes with 8 Ks or 9 Ks in between. So when I start it up, I go drink coffee. It's half an hour before it's finished. Well, you need to take 15 minutes before it's booted up, and then another 15 minutes because it needs to pull the config that I'm providing it. So 30 minutes that you're free to do it, whatever you want. Do something else. This also gives me capabilities to share my responsibilities. I'm just a developer, I do the coding, but I have no clue how the service works. If you ask me how Oracle SBC works, don't ask me, I'm a network guy, not a voice guy. So we can divide the tasks. What do you want to verify? This is what they can do, and they can build in the robot framework what do you want to see, and I can code it for them. But it's an ideal stage to have developers and operation guys work together. If you want to have functional tests that you want to expand, negative tests, whatever you want to do, it's a possibility. Work with the operation guys. They will find out from the people what is working, what is not working. They can maybe ask, can do it themselves to incorporate a test that's just specifically that scenario of the customer is testing. All right, I made it. Thank you. So guys.